So in exercise 2, we actually are going to build a model, but we're going to assign properties based on some fish calculations. So model new just resets the memory, gets rid of anything that was there, if we had any zones or any variable values, etc. We're going to set some fish variables right off the top. So we don't necessarily need to write fish define. In the old days we did. You would define it, then you would define all these values here, end it, execute it. But these little fish fragments are kind of a shorthand. You can almost think of these brackets as fish defined and end, if you will. So in this case, I'm going to define two global variables. It's a bit redundant, but you can kind of be able to see what the difference is. Young's mod, 5e8. Then I put a comma because we can actually define a series of global variables if we wanted to have just one or two or three. In this case, a p ratio of 0.25. Now we're going to derive our shear and bulk moduli. In this case, I'm using a local made-up variable called a factor. It just equals 1, so I won't change the answer. But it is a local variable. So if for some reason you did want to have a modulus factor, you could put it there, and nothing in the outside world can change it. So shear modulus equals this fictitious variable times Young modulus. So we're just converting Young's modulus in the P ratio, in the Poisson's ratio, into a shear modulus, and similar for the bulk modulus. We're going to run that. Fish function's aim is derived, so we're going to run that. And we're going to list the bulk, the calculated bulk and shear moduli. So I'm going to highlight all of that, and making sure to capture the new model new, run that selection. It's going to ask me if I want to keep the old data. I don't. I'm going to disregard it. And then here we can see that it's calculated a bulk of 3.3 times 10 to the 8 and a shear of 2 times 10 to the 9. One thing to point out, it's actually a bug. The global history here has disappeared. Normally that stays up as even after we do a model new. It's a bug. They've since fixed it. It'll be in the next version fixed. But if you find it's disappearing on you, it's just a temporary thing. Apologies for that. They're still baking it, if you will. So what we can do down here is we're actually going to build a model. So zone create 2D quad size. So it's going to be 20 by 20 zones, just a square little model. It's going to be elastic. Zone C model, the constitutional model assigned is elastic. And then we're going to assign zone properties bulk, that value that we calculated, shear that value that we calculated. And let's do that. We're not doing a model new, so everything's still in memory. I do a run selection, and there's two things. One, because we've listed it, it's actually showing us for every zone what those values are. So it's there's 400 zones, 20 by 20. So that's just also a way that we can see things like the properties in all the zones. And we can go, and if I go up to the selector, and I go new plot 1, I can go and add a zone, and I'm going to actually turn off the command section so I can see. So you can turn on and off all these different bits with these sort of toggle buttons down here if you need to have a little more working space. I'm going to turn the commands off so I can see my eyes here, do a contour, and I'm going to use a zone value of property down here in the list. And then you see there's a property name option. So these are the properties that I have if I do bulk. Now there's only one value for the whole model. Every zone is the same bulk, so it's not a very exciting plot. It's just gonna change these values in the legend, but the colors will be the same. But if for some reason something was happening in one of the corners of your model that was odd, you're getting lots of displacements where you're not expecting it. You know, maybe you've got the wrong property in there and it's being crushed, or maybe there's a boundary condition that's wrong and it's oozing out, so to speak. So I had actually meant to split this. So I'm going to split left so I can bring up that data file again, which was number 2. Okay. And just going to get rid of the plot. Okay, so that kind of gives you an idea. I mean, you know, maybe for a couple of variables, it seems like it'll work, but say you wanted to do hook brown constitutional model where you've got 20 different geotechnical units. And so instead of calculating everything on Excel, you can just put in the sort of inputs for your hook brown constitutional model and then just calculate everything in here. And then you can simply reference those variables when you're assigning properties. You can even write a fish function. There's pretty much a fish function for every command, not universally. If there is a command and there's a fish function, always default to the fish function. Let me rephrase that. If you're doing a fish function, we saw in one of the examples I showed earlier that you could put a command inside the fish function. If there's a fish equivalent to that command, always use that. Commands are really fast. They're the fastest. If you put a command inside a fish function, it will slow down. But a fish function within a fish function will be much faster. Sometimes you can't avoid it. In the old days, we didn't have a fish function that would delete zones. So you had to actually build a command in. So if there was part of the model that I wanted to rezone and increase the resolution of the zoning in an area on the fly, I'd have to go in there, look through all the zones, find the group that I was interested in, delete it, replace it with 4 or 8 other zones, and continue on. But now you can do that with a fish function.